Hello and welcome to this Java Crash Course video. Today we'll be going over everything you need to know to be able to code in Java. So let's get right into it, starting with variables. So, for most of this, I'm going to assume you have at least some experience programming in any other language. So I'm going to be going through things pretty quickly. So, we'll start off with variables. So what are variables? Variables are things that store information. To get more specific, they are pointers to a location in memory where a value is stored. Variables are used in every corner of programming. To do most anything. They're used in various statements, they're used pretty much everywhere. So they're important to know. And using a variable is pretty simple. So in Java, you write the type that the variable is, then a name for the variable, then an equals sign, and then what the value is. So if I wanted to have a whole number, like an integer, be int, say my number is equal to, let's say, 5. Now as you can see, I've written this variable with my, the m is lowercase, and n in the number is capitalized. This is called Camelcase. This is commonly used. This is the common syntax for Java variables. It's used to distinguish between different words in a variable name. So, like if I had a longer variable name, like let's see, I want to create a number, int age of current user is equal to 20. Of course, this is a very long variable name, and likely it was not something that you would use, but this sort of should give you a general idea of how that's used. More onto the variable types. There are a lot of different types of variables. So, as you can see, I've got an int here. There is also double, which is a short decimal. Float, which is a floating point number, which is a longer decimal. We have short, which is, I believe, a 4-byte number. Integer is 8 bytes, I believe. We have long, which is... So, integers go up to some number in the millions. I think it's 4 or 5 places long. At a certain point, though, integers won't really go up anymore, and you have to start using a long. Because an integer is an 8-bit number, a long, I believe, is a 32-bit number. That's the difference. For all the different kinds of numbers. And we have char, which is a single character, so I could say char letter is equal to, say, h. This would be just the letter h is a character. Char is a character, like the letter h. The number 7 in single quotes can be a character. The ampersand symbol is a character. That's what char is. And then there's string. So we use the full object of string here to make a string. String hi is equal to hello world. Now a string is an instance of char sequence. Like if I wanted to, I could also go char sequence hi is equal to hello world. Hi 2. These are pretty much exactly the same thing. String is the most common thing you will see. And then there are also collections, like lists, maps, sets. As you can see, there's list and array list. Pretty much anything you can instance can be a variable in Java. We'll get more into this when we talk about the object-oriented structure of Java itself and object inheritance. So we're going to move on now to conditionals and loops. This is the heart of programming, heart of basic programming. This is where you start to learn how to have programs make decisions. So we'll start off with something simple. So I'll say int my age is equal to 21. And we'll have int dad age is equal to 62. Those are just some numbers to use. So if I wanted to compare something, if I want to compare these two, this is what I use a statement for. So I would, if I wanted to say, if dad age is greater than 65, which it always is, which is why I'm getting that. If dad age is greater than 65, then, so we do if, then in parentheses is our statement. So we're saying if the variable dad age is greater than, with the greater than symbol, 65, then dad is, let's say, Boolean dad is senior. Say dad is senior is true. Else dad is senior is equal to false. Now, conditional statement is all well and good, but they're more useful. I'm struggling to think of the proper words. Okay. A conditional statement, this if-else thing, is all well and good, but it doesn't make much sense to be checking something like this when I have a value that is, for all intents and purposes, a constant. It would make more sense to receive input from the user and then compare that to certain things. So let's go ahead and get rid of all of this, and we'll do that. So to read in information, we use a scanner. So scanner sc, I'll call it sc, is equal to new scanner, in parentheses, in this constructor we pass system.in. What you pass in here, it's generally always going to be some kind of a buffer, but you pass in here what you want this scanner to be reading. So right now we're having it reading the system in buffer. Now we're going to print out a statement here. So we're going to say system.out.println, please enter your age. And I'll go int age is equal to sc.nextInt. This is going to get the next numerical value from the buffer. Now this is where we can start using a conditional. If age is less than 18, I'm in the US, the legal age of an adult is 18, and we'll say system.out.println, you are a minor. And we can add multiple layers to a conditional statement. So we have an if. We can also have an else if, which adds a second condition that we'll check. So if this first one is false, then we'll check the second one. So else if age is, let's say age is greater than or equal to 18 and age is less than or equal to, and age is less than 21. So that's always true. Okay. So if age is greater than 18, is less than 18, then we print out you are a minor. If age is less than 21, so if its age is greater than 18 but less than 21, system out print ln you are an adult but you are too young to consume alcohol. And I can say else if age is less than 65, system.out.println you are old enough to drink beer, let's just say. And the last condition is else you are a senior citizen. So an else statement is the last part of the if statement. So if none of the other conditions are true, then do whatever is in this block. You can't put another else if or another else after this. This is where this statement will end. Now, if I were to run this, conditionals, please enter your age. Say, I am 5. It tells me you are a minor. If I run this again, and I enter 17, I'm still a minor. That was a mistake. So enter 18. This is, I'm an adult, but I'm too young to consume alcohol. If I'm 21, I'm old enough to drink beer. If I'm 92, I'm a senior citizen. I'm actually going to have that on not a new line. Yeah. But now let's say I want this to keep repeating until a certain age is given. Or actually, let's do a guessing game for this. This would be better. So and this will have int guess. Please guess a number. So if I'll put on the top here, int number is equal to, say, 55. Actually, 2021, because that's the current year. So say if guess is less than 2021, system. Actually, I can also, because for if statements that have only a single line of code after them, you don't actually need the brackets. So I could just do system out.println too low. Else if guess is greater than 2021, system out.println too high. Else I'm going to print out you got it. So if I run this and say I enter 50, it says I'm too low, the program ends. If I want this to keep going until I guess correctly, this is where the loop comes in. So we're going to want to actually include the loop, the reading in part inside of the loop. So we're going to do that. But we need to also have a condition for to be met in order for the loop to end. Otherwise, the loop would go on to infinity. There's no actual way to programmatically check if a loop would in fact continue infinitely. It is there's a specific name for that conundrum, but it is an impossible question to answer via code, basically. By looking at the condition, one can feasibly determine whether or not it would run infinitely. But yeah, anyway, so I gotta create a condition for this to end the loop. So create a boolean guess correct is equal to false. Okay. And now we're going to use a while loop. So while, there are actually 3 kinds of loops. There are 4 kinds. There's while, a do while, a for, and for each. I'm going to go over all 4 of them, starting with the most basic, while. So I'm going to say while correct, and then I'm going to put all of this into the loop. And I'm actually going to add brackets here because I'm going to be adding a line to one of these. Okay. So right now, correct is false. Correct will never evaluate to true. So if I try to run this, it's just going to immediately end. So I need to tell this. The condition needs to be while not correct, keep running. So to indicate not in Java, it is an exclamation point. So I just put that before the word correct to make it while not correct is always true. For the moment, it's going to tell us that it's always true. But while not correct, now it'll actually enter the loop. The thing is, if I guess any number, it's going to keep looping. So we need to when the person guesses it, we need to update correct to true so that the loop ends. So now if I run it and say I guess 20, that's too low. Okay, I guess 200, that's too low. I guess 2,000, that's too low. I guess 3,000, that's too high. I guess 2,500, that's too high. I guess 2,100, that's too high. I guess 2020, that's too low. 2025, it's too high. 2021, I've got it. Program ends. So it goes until I give it something that causes this to become false. So it says while not correct, we loop. Correct is suddenly true, so this is saying if correct is false, loop. Correct is now true, so this is no longer, the loop ends, basically. The loop ends. The alternative to this particular kind of loop is a do while. It's basically the same thing, but instead we write do, and then at the end we paste this, while correct, while not correct, and we put a semicolon after it. So what's going to happen? So when you have a while loop, it's going to check the condition and then run the loop if the condition evaluates to true. On a do while loop, it's going to execute the sequence of code here, and then it's going to check the condition, and if the condition evaluates to true, it will loop again. Otherwise, it will just continue on. So like you would use this in a scenario where there's a chance that you might need to loop for something, but it's not necessarily a guarantee. So like this would still work exactly the same. If I give it 20, it's going to tell me it's too low. If I give it 200,000, it's going to or 20,000 is going to tell me I'm too high. If I give it 2021, it's going to end the program just like before. It's just a different kind of loop. These loops, while and do while, are most commonly used when you have a specific condition that you want to wait until it's met before continuing your code. The other kinds of loops, a for and a for each loop, are used when you want to iterate through collections. So we'll go over that next. First, I need to create a collection, so I'm going to go ahead and create a list of string my strings. It's a new array list. Go my strings dot add. Actually, call this names. Names dot add. We'll add Sean. Names dot add Rick. Names dot add Whisp. We'll start with that. So there are two different ways you can do the for loop. So there's the for loop and the for each loop. They can do similar things, but they're used for different purposes, and you'll see why in a minute. So I'll start with the regular for loop. So this one is going to be, and this one iterates until a condition is met. With numerical values. So for example, for usually the most common thing is int I is equal to 0, I is less than whatever the size is. We're going through this list of names. I would say names dot size I plus plus. So what this is going to do is for each. So it's going to start at 0, and then for each, so it says we create an integer I cited equal to 0. Then we check while I is less than size, we're going to run the loop, and when the loop has ended, we increase I by 1. I plus plus increments. The plus plus thing is a shortcut to adding 1. It's the same thing as doing I plus, or I is equal to I plus 1, or I plus equal 1. It's the same thing as doing that. So we're going to get for each item in the list, we can do some things. So these are just strings, so we can't really do much with them, so I'm just going to print it out. But so we'll do system.out.println names dot get I. If I run this, you'll see we get Sean, Nick, and Wisp printed out to the console. On this kind of loop, it is important to know where you are starting and what your upper bound is. If I wanted to start at, say, 1, then I would have to do while I is greater than or equal, or, okay, never mind, ignore that. So, the reason why I've started with put int I equal 0 is because the way collections work in pretty much every programming language, they start at 0, not 1. So if I were to put int I is equal to 1, I would have to say while I is less than names dot size minus 1, or I would have to subtract 1 from I before I look at it. But yeah, so I'm tired. If I let's just say I was I added 1 to this on accident. You're going to see what happens here. We get an error. This exception in thread main java.lang.index out of bounds exception index 3 out of bounds for length 3. So I tried to look for something at an index of 3. But that doesn't. There are 3 items in the list, but the indexes are 0, 1, and 2. There is no index 3, which is why that error happened. And as you can see, it tells me which line it is, and I can click on that, and it will link me right to this because IntelliJ is good. Touch the for loop. Next is the for each loop. So this one is if you're going to work specifically, if you need to do like a specific operation with every single item in a collection. And you don't need, and indexes are not going to be important to any of the things that are going to happen within the loop. So I could do for string name in names. This colon is sort of the what it goes in place of in. So for each string that is contained within this list, we're going to put it into this variable name, and I can go system.out.println name to print out the name. And if I run this again, you'll see Sean, Rick, and Whisp printed out into the console. So that basically is conditionals. So let's move on to functions. This is really the last thing, actually almost second to last thing before we can get into the object-oriented structure and finally the graphical interfaces. So functions are functions are used in every single program you look at. You're going to find various functions, no matter what the program is, unless it's this like a really, really short program that doesn't really do it. That's like if it's written in Python, for example. You could create a program that is literally just print hi. That technically doesn't use any functions. It's just whatever the main is. But like in Java, every single program in existence uses a function, because this right here, this public static void main string array args, is a function. It is the main function. When you press the play button, this is what what Java is looking for to run. It's going to look for a main within the compiled class, and when it finds this method, it'll run the program. If this doesn't exist, the program will not run, and it will say the main could not be found. Now, functions are broken up into a few different parts. So, in Java, there are a number of different things to it. So we have the first part here where it says public. This is the access type of the function. This is can either be public, private, or protected. And I will discuss this in the next section. And then we have this. This might not always be here. This is static. Static versus non-static is also going to be explained in the next section. This is static because the main is going to be run from the start of the program. It's not going to be instance. It's just going to be executed. Then we have the name of the function, which is main, and then any parameters. So main only takes an array of arguments. This is command line arguments. So if you were to type in actually a good example is well, I was gonna say a Minecraft server. Let me just pop open CMD. So if I wanted to run a Java program, let's say I have a jar called do math, and let's say like print name, for example. I would say, so I would run the program with Java -jar print name.jar. Let's see how I pass Holly and Bell. Holly and Bell are arguments that would be passed into this string array args parameter. Functions can be used for a lot of different things. You use them if you're doing recursion. You can use them to run specific operations. They can be used to modify variables in a class, for example. A class is a Java file, the .java file. They're used for a whole lot of different things. So let's go ahead and create a function here. Let's call it. I'll make this one for now just public. Public has to be static because I'm calling it directly from the main, which is also static. Void main. Which I will explain more later. Let's see. This one is going to take, say, int a, int b. Actually, I'll make this a Boolean, and no, make this an int, and we'll just call this function greater. So what this function is going to do is it's going to return the greater number. This is going to be a kind of weird statement. So we're going to say return a greater than b question mark a comma b. I think I did that right. Can be replaced with math.max call. Yeah. Okay, so I suppose we could just do that, but I want to do my fancy stupid thing. There's a greater than b question mark. Return a if true, otherwise return b if false. So say int result is equal to greater 5 and 10. System out print ln, we'll print out result. Oh, whoops. Ran the wrong file. So we got 10 because 10 is greater. It actually probably would be better to just do math.max. So this actually also is a function call. This is a static function call. Again, I'm going to explain that more in a minute. But yeah, so I'm passing in a and b, which are both integers, into this greater function, and it's going to tell me which one is the max. Now, this is asking for both an integer for a and an integer for b. Now, if I tried to pass in a decimal, 5.0, it's going to tell me I can't do that because this function, only takes integers. One thing I don't know if I mentioned, in Java, functions are called methods. In pretty much any language, they can be interchanged. I mean, each language is going to call them differently. Like in Python, you call them functions. In Java, they are called methods. I don't know what they are in C. Or in C, they're functions. I don't know what they are in C# or C++. It doesn't really matter. But yeah, that's basically a function. They're pretty simple. It's basically just like you can create something that you can then call from anywhere. So like I could create this, and I could create more functions, and I could write a whole bunch of code and then call it based on conditionals. So like you would have like a conditional statement, like if something is like perform an operation, if the result is true, call this function to perform another operation. If it's false, and call this other function or return or whatever. I mean, it's the way these things are used very much depends on the circumstance. But yeah, a function is something you can call, pass items to it, and it will do an operation that is removed from whatever you're currently in. This is very important, great, very used. Gosh, I'm screwing up words again. This is very important for keeping your code organized. So that way you don't have like a single method that's like 500 lines of code long. You'd split things up into functions. This also can save you from repeating bits of code. So like if I was going to compare 6 different numbers to see which one is greater, I could say which one of these I could write out 5 different operations to see which one is greater, using the same exact thing, writing math.max a b every single time. No, that's not really a good example. Well, okay, here's one. So let's say I have a program that is going through a that has 2 things that happen in it. One, it scans through a list of, say, users, and for each user, it's going to see what it's going to. Oh God. Okay. I can't think of any actually good examples of this off the top of my head. I gotta think of something here. Okay, here's one. Let's say I have a set of oh God, I lost it. Okay, let's say I have a set of numbers that I need to do a series of complex calculations with, and I need to run a calculation on a number, and then at some point double check the number. So I would have this calculation code in 2 different places. Rather than do that, I write the code once in a function, and then I call that function passing in the number that I want to do the calculation on each time. An example of this, let's say I'll pass in int A, B, and C. I'm going to write out the quadratic equation here, basically. Real quick. This is a good example of this. So, we're returning an int is going to be the result. So the formula for finding x in a quadratic equation is x is equal to negative b plus or minus the square root of 4ac all over 2a. So we have int, I'm not going to worry about putting this as decimals, but int x is equal to x equals negative b is equal to negative b. I'm only going to use half of the equation. So x equals negative b plus or minus the square root of 4. So int root of 4 plus a plus c equal 4 plus a plus c. Root is equal to math.sqrt root. It's giving me a double. I'm going to just cast that to an int because I can do that. This is basically saying, so math.square root returns to me a double, but this is going to convert that to an integer, which is going to chop off the rest of the decimal, which is going to make a very inaccurate number, but I don't care. Plus x equals negative plus minus the square root of 4ac all over 2a. Okay, so we're going to say x plus equal root and x is equal to x divided by 2 x plus a. Return x. So this is a fairly long computation. Let's say I was computing this for the value of 3 different quadratic equations. Let's say I'm doing it for x squared plus 2x plus 4. So that's 1, 2, and 4. So we'll create it with, and maybe 1, 2, and 5. That's 2 different equations. Rather than typing that out twice, I've typed this out once, and now I can call greater with 1, 2, and 4, and greater with 1, 2, and 5, and I can get my responses without having to retype this code a whole bunch of times if I'm doing like the square roots of multiple things. So that is the importance of a function. That section took longer than I meant it to. Next, we're going to talk about I'm going to combine these together. Object orientation and inheritance. So, first, I got this extra main class. So, what is an object? An object is basically anything you can make an instance of. So, anything you can... So, like, if I were to create an integer of 5, so int number is equal to 5, number is an object. It is an object of the type int. Number has different things that I can do to it. Well, not a whole lot because it doesn't have any numbers. It's not a native type, but like if I were to create a list, for example, a list of strings, Okay, I apparently accidentally knocked out the cord from my microphone, so I lost a little bit there. So I'll pick up for, I think, where I was. So I was looking at the list. I created that as an object. This is an instance of my list. And I had realized as I started going over what objects were that it would be useful to talk about the access types for public, protected, private, and the difference between static and dynamic, or static and non-static. So I went into the users class and I created 3 variables because this is the kind of things you might find in a user. Our user's going to have a name, an email, an age, maybe a password. I'm not going to do a password for here, but when I went over to the variables class that we heard this in before, so you notice here all of these variables, they don't have anything that indicates public or private or anything before them, and these are declared inside of the main function. So these are local variables. These variables can only be accessed inside of the main. If I were to create another function, public static void alt, there's nothing, and I try to use my number is equal to 7, it's not going to work. It's going to tell me that that number doesn't exist. So getting back to the users class, these have not been made inside of any particular method, which means these are global variables. This is common for storing information in an object. I want to store this specific data. It's going to be used by all the different methods inside of this class. So it should be accessible by all of them, which means I'm going to put it up top before any functions. And it's also going to have this part that tells me how it can be accessed, and this is called a global variable. Now, these are all marked private. Private means that these variables can only be accessed by the user class, particularly the instance of the user class that they are in. I cannot access them from any other class at all. Now, if I were to change this to protected means that any other class within that same package can access it. So, if we're inside of this object orientation and inheritance, this is a package. All of these classes I could access name from. So, an example of this, if I go into here and I go user is equal to new user dot, as you can see, I have access to name out here, but I do not have access to email because email is private. However, it can only be used inside of that package. So if I go into access types, this class here, and I go user is equal to new user, and I go user dot, as you can see, I no longer can access name because I'm not in that package anymore. The third type is public. If I change this to public, it can be accessed from anywhere within the program, which means I can access it here in this other package. Now, these variables, you only want to be accessed from here. Now, these indicators are also put on methods and also on classes. So like this public class user, if I wanted to make a protected class, if I wanted this to actually be protected, I guess I can't do that. I can do private, though. Okay. The main class that a .java file, a class file, contains has to be public because it has to be able to be instanced by other things. An inner class, which I will discuss when I get to the graphical interfaces, that can be different. However, I can make... Okay, never mind. Ignore that. That also is only for inner classes. Which I'll get to later. But yeah. So the main class in a .java file has to be public and not static. Now, what static means is that method can be accessed without the object needing to be instanced. So I'm gonna finish building this user object here for this example. So public user is going to take a string name, string email, int age. Now here's a little trick. So I've given this is a constructor. So this is like when I create an instance of this object, I have to pass in these three things, or I can't actually make an instance of it. Now these are the same names as these these variables up here. Now there's a little trick to being able to set these equals. So if I just do name is equal to name, you notice it turns gray like this because it's saying this name or saying that name equal to itself, which is kind of pointless. But I want it to be part of this variable up here. So I would say this dot name is equal to name. What this is saying is the name variable that is part of the class. This one right up here is going to be set equal to the name that is here. And I'm going to do this with email, and finally with age. So now my user has three different variables that have been set. Now I might want to be able to manipulate some of these values. So I could say public void set name string name, this dot name is equal to name, and public void set age string or int age, this dot age is equal to age. One thing I realized I forgot to talk about when I was talking about functions is what this part is here, where I wrote void. And when I was talking about functions, I should change that to an int. That is the return type. That is what this function is going to return. So if I label this void, this function returns nothing. It means it's going to return nothing, which means I don't need to put a return in. But I added the word int here. That means that this function returns an integer, which means I have to somewhere in my code write the word return followed by some integer value. So that's going to be what I'm going to do here when I create the getters. So public string get name return name, public int get age return age. Right? Now there are two more things that I'm actually going to do with this object, and this gets more into sort of inheritance, which I'll talk about in a little bit more detail. Actually, no, I'll leave that off for now. I'll do that later if I do it. It's not really that important. So now I've created this user object which contains these various items. I'm not going to worry about doing a getter and setter for the email because I don't want to take up too much more time. This is an object, and I can do things with this object. So I can instance this. So say user is equal to new user, and I gotta pass in, say, Whisp email of Whisp at wispwriting.net. Age is 21. That is my actual age. Now I've created this instance of user, and I can go user dot get age, get name, set age, set name. Now let's say I wanted one more variable in this. I wanted something that keeps track of the number of users I have in the system. That's something that you would find in the users class. but I don't want that to be instanced with the rest of the object. Well, I would do something like this. It's going to be still private, but it's going to be static int number of users. Now, when I create an instance of this, I'm going to call number of users plus plus, which is going to increase the number of users that I have listed. First, I'm going to leave the static part off and just increment that by 1, and then have a public void get count return number of users. Not bad, that used to be in it. If I go here, I've created one user. Let me create another user. So I'll create user 2 equal to new user. Let's call it guy email 30. Okay. So if I do system dot out dot system, what the heck? System. Oh, whoops. Call it systems. So I want system out println say user dot get count, and system dot out dot println user 2 dot get count. Okay, now if I run this, you'll see just 1 and 1, which because each user had this incremented only once. Now if I change this to static, now when I run this, they say 2, because I created the first user, it incremented this by 1, and this variable is static, which means it is the same across all instances of the class. Now, let's say I didn't want to have to use the user variable, an instance of the user to get that variable specifically. I just wanted to, from any user, get the count. Then I'll go to this get count method and add static. And now, okay, so before, if I leave it like this, oops, not what I wanted to do, and I try to call directly on the class user dot get count, as you can see, I get an error. It actually tells me that that's a non-static method. I'm actually going to call this user1, so it's not confusing. And if I go ahead and add static to this, now I can call that method just on the class directly. So no matter how many users I have, I can just call that, and it'll give me 2. So if I add, say, a third user, now the count will be 3. Now, part of the usefulness of an object-oriented structure is being able to pass messages around. So I'm not really going to write the code for this because I'm going to try to move along. But systems would be another object. It would have what a system would have. It's going to have a collection of the users in a list or a map. It's going to have something that allows me to add a user, something that allows me to delete a user, maybe something that allows me to search users. And in the search users function, it's going to go for user in users user. Then I will call a method from user. I'll say user dot get name equal. I'll write that part. Okay, I'll do this part. So private list string users equal to new array list. This is just going to use the default constructor, so no constructors. And create a user is going to be public void create user string name string email int age. And then I'm going to go ahead and take this code here, and I'm just going to go users.add new. Oops. I'm just going to add an instance of the user class with a. Oh, whoops. I want that to be user. Okay, there we go. I'm not gonna do deleting user, it's too much time, but now let's say I want to also have a thing that searches for a user, so then I would do I can do two different, so I'll go public so I'll go public user search, passing in string string, and I can actually do two of these. So I can do public user search int number. This is totally feasible. I've done it. This is called an overloaded method. Basically, it's a method with the same name, but the parameter is of different type, different parameters, basically. So what I'm going to do is for user in users, if user.get name dot equals string, return true, or return user, and if we get to the end, return null. And this one is basically going to be the same, but instead I'm going to get age is equal to number, return user. This is a systems of it. I don't remember why I actually just created this, but yeah. And then I could call this any number of times, create any number of users. I could search the users, and the system is talking to the user, asking the user what its age is, basically, to see if its age matches what I would have passed into this. Now let's say, this is more into inheritance now. Let's say I want to have an employee class that is going to be a type of user. So, like, if this is like an account system for a company, you might have an employee and then your customer. They're going to have the same core values, a username, an email, a password, and an age, but then they might have some differences. like a customer, you might have their phone number and their credit card information. An employee, you might have like an ID. So, but I still want to have the rest of user. So to do that, I can use inheritance. So in order to, I can have this class extend user, by literally typing the word extends user. There's no default constructor. And I can make a class it can be an instance of user. Now, this has to have a matching constructor of the superclass, so I have to have this, and then, so I have to have a constructor inside of this that calls this constructor up here, which is what this is, and then these particular variables, these values, need to be passed into that constructor, which is called the super constructor, which is part of the superclass, which is user. So I call super and then pass that stuff in, and now I've got an employee essentially, but the employee is going to have more to it. So private, say string, or I'm going to say long employee ID, and I want to add on long employee ID